Hello students, welcome to another session of this miscellaneous exercise chapter 2 inverse trigonometric functions. In the last session I solved 8 examples and remaining examples will be solved in this session. So here is the first example. Prove that tan inverse of root x is equals to 1 by 2 cos inverse of 1 minus x by 1 plus x. Okay, so begin with right hand side. So consider right hand side as this. Okay, so consider RHS. We'll write RHS equals to 1 by cos inverse of 1 minus x by 1 plus x, and bring in your mind the trigonometric identity, that is 1 minus tan square by 1 plus tan square will be cos 2 theta. Okay, so we substitute here x is equals to tan square theta. So put x equals to tan square theta, so which implies square root of x is equals to tan theta. Okay, so we substitute here what the RHS becomes. So RHS is equals to, it's 1 by 2 cos inverse of, it is 1 minus tan square theta divided by 1 plus tan square theta. Okay, now see here, you know this identity and I told you earlier also, cos inverse of 1 minus tan square theta by 1 plus tan square theta, it is a cos 2 theta, so you can write it as cos of 2 theta. Now it's 1 by 2, and as you know cos inverse of cos gets vanish and you left with 2 theta. So 2 cancels, it is theta, which implies theta is tan inverse of root x. Why? Because here, because earlier I have written that tan theta is root x. Okay, so theta is equals to tan inverse of root x. So this is your left hand side. So you proved your required result. So only thing is that you must know trigonometric identities and proper conversion. Okay, so let's have another example. Here is question number 10. Prove that cot inverse of 1 plus under root 1 plus sin x plus under root 1 minus sin x divided by square root of 1 plus sin x minus square root of 1 minus cos x equals to x by 2. Okay, so consider LHS, left hand side, consider this thing, you have to write this. Then here you need to rationalize this inside term. So multiply and divide by taking plus out here. Okay, then rationalize ಮಾಡೋದು. So what will get? You will get cot inverse of, so multiply and divide by this with plus sign. So you will get root of 1 plus sin x plus root of 1 minus sin x into same thing root of 1 plus sin x plus root of 1 minus sin x whole divided by root of 1 plus sin x minus root of 1 minus sin x plus into root of 1 plus sin x plus root of 1 minus sin x. Okay, multiply and divide by conjugate of this, that is taking rationalization factor plus here. Okay, we have done it. Okay, now simplify it. This is cot inverse of, okay, in the numerator it becomes perfect square. Okay, so two same terms you can write it as a root of 1 plus sin x plus root of 1 minus sin x whole square. And in the denominator you are having terms of the form a minus b, a plus b, that is a square minus b square. So you can write it as square root of 1 plus sin x whole square minus square root of 1 minus sin x whole square. Okay, because denominator is of the form a minus b, a plus b. Remember this. A minus b into a plus b is a square minus b square. Okay, so same thing we have done here, which is equals to cot inverse of, okay, you expand it using a plus b whole square formula, that is a square. So root of 1 plus sin x whole square plus b square root of 1 minus sin x whole square and plus 2ab, that is 2 into root of 1 plus sin x into root of 1 minus sin x. Okay, a square plus b square plus 2ab. In the denominator, okay, square of 1 plus root sin x whole square is, it is 1 plus sin x minus square of this root is again 1 minus sin x. Okay, so now simplify cot inverse of, so this becomes 1 plus sin x, square root get cancelled. This is 1 minus sin x plus 2 into under root, you will get 1 plus sin x into 1 minus sin x. Okay, in single root you write. In the denominator open the bracket. If you open the bracket, 1 plus sin x minus 1 and this is plus sin x becomes minus of minus plus, this into this becomes plus sin x. Okay, now check the terms here, sin x cancels. Okay, so and in the denominator 1 cancels. So what will be left with? You are left with cot inverse of 1 plus 1 2 plus 2 into under root, it is 1 plus sin x into 1 minus sin x, that is a plus b into a minus b, that is a square minus b square. So you will get a square means 1 square is 1, so a square minus b square. In the denominator you will left with 2 sin x. Sin x plus sin x is 2 sin x. Okay, this is cot inverse of 2 common 1 plus under root 1 minus sin square means cos square divided by 2 sine x. Okay. Which is equals to cot inverse of 2 cancels. So 1 plus square root of cos square is cos x, which is divided by sin x. Okay. Now we need to express it in the simplest form. Okay. So we know that cot inverse of 1 plus cos x means it is 2 cos square x by 2. In the earlier also I told you, very important. Okay, sin x in terms of half angles, 2 sin x by 2 cos x by 2. This was also given. Sin x in terms of half angle, 2 sin x by 2 cos x by 2. Okay, now you are at the end. 2 cancels, 1 cos cancels. So you are left with cot inverse of cos x by 2 by sin x by 2. Okay, so which is equals to cot inverse of cot x by 2, and at the end cot inverse cot gets vanish. You are left with x by 2. So this is your required result. So only thing is that you must know all the trigonometric identities to establish such results. So let's have another example. Prove that tan inverse of square root of 1 plus x minus square root of 1 minus x divided by square root of 1 plus x plus square root of 1 minus x equals to this, pi by 2 minus 1 by 2 cos inverse x. Okay, so consider left hand side. So consider LHS is equals to this. You have to consider this. Okay, now you need to make substitution. Put x equals to cos 2 theta. Why cos 2 theta means 1 plus cos 2 theta is 2 cos square theta. So remember this. We have 1 plus x here. So 1 plus x means 1 plus cos. It is 1 plus cos 2 theta. And 1 plus cos 2 theta means 2 cos square theta. Remember this. And 1 minus x. 1 minus x means 1 minus cos 2 theta, which is 2 sin square theta. Okay, so that is the reason you need to put x as cos 2 theta. So substitute. So therefore LHS becomes, your LHS is tan inverse of, so we have under root there, so you have to write in root of 2 cos square theta minus of root of 2 sin square theta divided by root of 2 cos square theta plus square root of 2 sin square theta. Okay, because here we have root of 1 plus cos minus root of 1 minus cos, similarly in the denominator. Now check. This is tan inverse of root 2 square root of cos square means cos theta minus root 2 into sin theta you will get. Okay, square root of sin square is sin, divided by similarly root 2 into cos theta plus root 2 into sin theta. Yes. Okay, after this divide both numerator and denominator. Okay, you have to divide both numerator and denominator by this term root 2. You have to divide numerator and denominator by root 2 into cos theta. Okay, so now check what it will get reduced. So what will get? Root 2 cos theta by root 2 cos theta means 1 minus root 2 by root 2 cancel, sine by cos remains, that is tan theta, divided by this becomes 1 and this is plus root 2 cancel, sine by cos is tan theta. Okay, now see here, this 1 minus tan theta by 1 plus tan theta. Okay, so you better remember this. This is of the form tan inverse of x minus y by 1 plus xy. Either you can remember in that fashion. Okay, I can write it in this form. Tan inverse of tan theta. Okay, because see here, because tan inverse of x minus y by 1 plus xy is your tan inverse of x minus tan inverse of y. Okay, we have used that. Here x means 1. Okay, so and y means tan theta. So this is that. Now you can write what is tan inverse 1. Tan inverse 1 is pi by 4 minus tan inverse of tan theta is theta. Okay, now you need to write what is theta. But you have, but what? Substitution is cos 2 theta is equal to x. So 2 theta is cos inverse x and theta is 1 by 2 cos inverse x. Okay, so your this equation becomes, so left hand side becomes pi by 4 minus theta means 1 by 2 cos inverse x. Very easily you can prove. Only thing is that you must have patience. Okay, so need to work at least once or twice, then your confidence will be high. Okay, so let's have another example. Prove that 9 pi by 8 minus 9 by 4 into sine inverse of 1 by 3 is equal to 9 by 4 into sine inverse of 2 root 2 by 3. Okay, so simple, looks complicated one, but it is simple. Consider left hand side. Consider this left hand side. Okay. Now see here, in the required result we want 9 by 4 common. Okay, factor. So here it is possible to take 9 by 4. So take 9 by 4 common. Taking 9 by 4 common. Okay, what you will get? So if you take 9 by 4 common, here you will get pi by 2. Okay, because 8 means 4 into 2, so 4 is taken, 2 remains. Minus 9 by 4 is taken outside. So sine inverse of 1 by 3. This is equals to 9 by 4. Okay, pi by 2 minus sine inverse of 1 by 3. You may write it as cos inverse of 1 by 3. Take cos inverse of 1 by 3 is equal to, say, x. So this becomes what? Cos x is equals to 1 by 3, and from this, if you draw right angle triangle, this is your x, this is your adjacent, and this is your hypotenuse, and this can be calculated as, this is 3 square minus 1 square, and that gives you 8. Okay, so 3 square is 9, 9 minus 1 is root 8, and you can write it as a 2 root 2. Okay, so this opposite side is 2 root 2. So now you can write this in terms of sign. So therefore your sin x is what? Sin x is 2 root 2 by 3, and this implies x is your sine inverse of 2 root 2 by 3, and x is what? Your x is cos inverse of 1 by 3, which can be expressed in terms of sine inverse as this. Okay, so look at that. Cos inverse you have got. Cos inverse is this. So therefore LHS becomes, is, it's 9 by 4 into cos inverse 1 by 3, and cos inverse 1 by 3 is this much. It is sine inverse of 2 root 2 by 3. Okay, so this is your required result. Let's have this. Solve the equation 2 tan inverse of cos x equals to tan inverse of 2 cosec x. Solve means you have to find the value of x. Okay, so consider this as given. So given is this. So now look at this, 2 tan inverse cos x. So use this formula. Use 2 tan inverse x is equals to tan inverse of 2x by 1 minus x square. Okay, in the left hand side you have the same form, 2 tan inverse x. Okay, so I can write this as, this is of the form 2 tan inverse x, but x is cos x. So this is tan inverse of 2 cos x by 1 minus cos square x. Okay, 2x by 1 minus x square. Okay, on the other side, tan inverse of 2 cosecant x. Okay, now both sides you have tan inverse, they get vanish. You can write 2 cos x by 1 minus cos square means sin square x equals to 2 cosec x, 2 cosecant x. Okay, both side 2 you can remove, and which implies cos x by sin square x equals to, cosec means you can write as 1 by sin. Okay, now one sin term get cancels, So you're left with cos x by sin x, that is cot x is equals to 1, and which is x equals to cot inverse of 1, and cot inverse of 1 is known to us, that is pi by 4. So this is your value of x. Okay, so this is the required solution. Let's have another example. This, solve the equation tan inverse of 1 minus x by 1 plus x, okay, equal to 1 by 2 tan inverse x is given. So you are supposed to find the value of x. Okay, so straightforward, this is your given, write this given. Okay, so write given as this, and as earlier, this can be written as tan inverse of 1 minus tan inverse of x. Okay, because if you use the formula for tan inverse x minus tan inverse y, you will get this. What is tan inverse x minus tan inverse y? Tan inverse of x minus y by 1 plus xy, and that is here, equals to 1 by 2 tan inverse of x. Okay, so note down this, tan inverse x minus tan inverse y is this. Okay, now tan inverse of 1 is pi by 4, and you can transfer this side, you will get tan inverse of x plus 1 by 2 tan inverse x. Okay, so which is equals to pi by 4, that is, this implies pi by 4 is equals to, add this 2 into 1, 2 tan inverse x plus tan inverse x, taking LCM, 2 tan inverse x plus tan inverse x by 2 you will get. Okay, which implies pi by 2. Okay, both side 2 in the denominator, so cancel this, 2 2s are, so pi by 2 remains here. This is 3 tan inverse x, 2 tan inverse plus tan inverse is 3 tan inverse. So this implies tan inverse of x equals to pi by 6. Okay, this 3 comes down, 3 into 2 is 6. This implies x equals to tan of pi by 6. Tan inverse x equal to pi by 6 means you have to write x is equals to tan pi by 6. And what does it imply? What is tan of 30 degree? Tan of 30 is 1 by root 3. So this is the required solution. Okay, so let's have another example. Here is sine of tan inverse x is equal to dash. You're given these 4 options and you have to check which is correct one. Okay, so given is sine of tan inverse x. Okay, maybe from the point of CET this will help you. So if I take tan inverse x is equals to y, so this becomes tan of y is equal to x. Okay, so if I put this in the form of right angle triangle, see here, if I draw a right angle triangle and if I take this as y, tan is what? Tan is, it is opposite by adjacent. Okay, so opposite is, this can be written as x by 1. So opposite is x and adjacent is 1. Now you need to calculate this hypotenuse. It is actual what? Sum of the squares of these two under root. So it is 1 plus square root of 1 plus x square. Okay. So you got that. So this implies what is your sine y. Because look at this. We want sine of tan inverse x. Tan inverse x is y. Okay. So what is y you need to find? So sine of y is equal to, it is x by root 1 plus x square. So what does it imply? This implies sine of y means what? Y means it is tan inverse of x is equals to x by root 1 plus x square. So this is your correct answer. So check your answer. So this is fourth option. Okay. So in this way you can prove this. Let's have another example. Same multiple choice question. If sine inverse of 1 minus x minus 2 sine inverse x equals to pi by 2, then what is your x? Okay. So here consider, if we consider this, whatever given, consider this. So, and put, if you put sine inverse x is equals to y, this I will take it as a y. Then what will happen? See here. This implies sine of y is equal to x. Okay, sine inverse of x equals to y means you can write x is equal to sine y or sine y is equal to x. So what this one becomes? Sine inverse of sine inverse of 1 minus sine y you will get, minus 2y equals to pi by 2. This implies sine inverse of 1 minus sine y equals to pi by 2 plus 2y, which implies 1 minus sine y is equals to sine inverse of, this means I can write sine of pi by 2 plus 2y. Okay. So sine inverse this side, if you remove, on the other side you have to write sine, which implies 1 minus sine y is equals to, now tell me what is sine of 90 plus theta. Sine of 90 plus theta is cos theta. So I can write cos 2y. Do you remember that? Sine of 90 plus theta, note on this, because sine of pi by 2 plus theta is cos theta. Okay, so that is we are writing here pi by 2 plus 2y means theta here. So it is cos 2y. So this implies 1 minus cos 2y equals to sin y. Okay, so I bring this minus sign this side and cos 2y this side. And as we all know, 1 minus cos 2 theta is 2 sin square theta. So I can write it as 2 sin square y equals to sin y. Okay, you need to solve it. So 2 sin square y minus sin y equals to 0. And this is a trigonometric equation. So sin y common. This is 2 sin y minus 1 you will get. Okay. So this implies sin y is equal to 0 or 2 sin y minus 1 is equal to 0. But what is your sin y? Look at this. Your sin y is x. Okay. So this implies your sin y means x. X equal to 0 or 2x minus 1 equal to 0 because your sin y is x. Okay. So this implies x equal to 0 or x equals to 1 by 2. Now you have got two answers, that is two solutions, but whether you have to check both of they are satisfying the given equation or not. Okay, because in the option you have various possibilities: 0 1 by 2, 1 1 by 2, 0 and 1 by 2. Okay, now if you put x equal to 1 by 2 here, check here, if you put x equals to 1 by 2, what will get? 1 minus 1 by 2 is 1 by 2 and 1 by 2. So sine inverse of 1 by 2 minus 2 sine inverse of 1 by 2, you will get minus sine inverse of 1 by 2, and which is not equal to this. Okay, so 1 by 2 does not satisfy this equation. But if you put x equal to 0 here, sine inverse of 1 minus 2, if this becomes 0, so 0 satisfies this equation. Okay, so you can conclude that here x equal to 0 only satisfies the given equation. Therefore the solution is x equal to 0. So x equal to 0 is the solution. Because x equals to 1 by 2 does not satisfy the equation. You can verify it. So that is why correct answer is your option C. Your option C is the correct answer. So let's have one more. That is last of this session. Tan inverse of x by y minus tan inverse of x minus y by x plus y is equal to which? So very simple. You have to use that tan inverse x minus tan inverse y formula. Okay, consider this and you need to work out. Tan inverse x minus tan inverse y is tan inverse of x means x by y minus x minus y by x plus y whole divided by 1 minus this 1 plus x by y into x minus y x plus y. Remember the formula, tan inverse x minus tan inverse y is tan inverse of x minus y by 1 plus xy. Okay, rest of the thing is simplification, which is equals to tan inverse of Take LCM here. This into this. X into x plus y minus y into x minus y in the denominator. Okay, you will get y into x plus y whole divided by, similarly take LCM in the denominator. Y into x plus y comes here. Y into x plus y plus x into x minus y whole divided by, it is y into x plus y. Okay. Now whatever the terms get cancelled, cancel. This y into x plus y into x plus y cancels. So simplify numerator, tan inverse of x into x square plus xy minus xy plus y square divided by x into y xy plus y square plus x square minus xy. Okay. So xy cancels in the numerator and the denominator. So you are left with tan inverse of x square plus y square by x square plus y square, and that will also get cancelled. You are left with tan inverse 1. Tan inverse 1 is pi by 4. Okay, so now you can check your answer. So option C is the correct answer. So this is all about miscellaneous exercise 2, and I hope you all have enjoyed it. So if you really enjoyed, then please don't forget to comment. Okay, so in the next session we are coming with another new chapter, that is matrices. Okay, so till then, take care and bye bye.